Okay, so this is going to be your Unit 1, Day 3 lesson video, and here we're going to cover dimensionality and the quantification of space. So here's our 5 EQs to kind of walk us through this. So why is it important to quantify space? What is distance? How can we calculate 1D distance? How can we calculate where a midpoint exists in 1D? And how can we calculate where a point exists at a fractional distance between 2 points in 1D? Okay, so why is it important to quantify space? So to put it simply, it's important to do so, well, because it helps us define our reality. Okay, so imagine if we didn't quantify space, if we didn't have units of measure to tell us how many miles apart something was, or how tall something is, or how heavy something weighs, and yada, 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 right? So we have to have that. Okay, so what is distance? So distance, to put it simply, is a 1D measure of space between 2 points. Okay, so point A, point B. And anytime I say 1D measure, I also am saying a linear measure. Okay, so anytime you hear me say linear, right, know that I'm talking about one-dimensional. Okay, so we're not really going to work through this part in the video. I'm going to go ahead and get right into one-dimensional distance. Okay, so let's say I was trying to find the one-dimensional distance between 2 points on the number line, so 4 and 16, right? What is the distance between 4 and 16? Well, if this was my point x1 and x2, right, it would simply be 12. Okay, and that's because the absolute value of the difference between 4 and 16 is equal to that distance, right? And if you count, so 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? If you actually count this all out, okay, you end up with 12 ticks between 4 and 16, or from 4 to 16 rather, right? So the distance between 2 points in one dimension, right? So one-dimensional distance is simply is simply 1 point minus the other, and you take the absolute value of that, which is what these bars mean. Okay, because when we measure distance, we measure in terms of magnitude. There is no positive or negative. There's only just the magnitude, the absolute value. Okay, so another example here, right? So 10 minus 14, or the distance between, again, 10 and 14. This should be x1, x2, right? Obviously, they're 4 apart. And if we utilize this formula here, our distance in one dimension between x1 and x2, or 10 and 14, is simply going to be the absolute value of -4, which obviously is 4. Okay, so pretty simple, pretty straightforward. And we've got a few more examples here. So I already did number 1 and number 2, right? What I'm going to do now is go ahead and calculate distances between 3, 4, and 5. Okay, and then I'll also go ahead and elaborate into midpoint here in a second. So one more example, and then we'll talk about midpoint. Okay, so the distance between x1, x2, that's quite simply going to be -7 minus 5. Okay, and my absolute value there is going to be 12. Because -7 minus 5 is -12. The absolute value therein is 12. So the distance, the magnitude between these two numbers is 12. Okay, so midpoint on the other hand, so here's -7, here's +5. We know that the distance between them is 12. So that means our midpoint is right here, right? Which means 6 this way from the midpoint and 6 this way from the midpoint. Okay, so if I just add 6 to x1 or subtract 6 from x2, that's going to take me to this midpoint M here, right? And it turns out all that comes down to is x1 plus x2 all divided by 2, right? So what my midpoint ends up being, obviously, is -1 right here in the center. So my midpoint is -1. So let's see if this formula actually works out the way that we need it to. So x1 is -7 plus 5 all over 2. We end up with -2 over 2. And holy dog crap, that is in fact -1. Okay, so pretty straightforward. And that's exactly how this formula works every single time, over and over and over again. So let's do another example. Oops, I just did number 3. Number 4. Okay, so my midpoint is equal to x1 plus x2 over 2, or -1 plus 3 over 2. That's going to give me 2 over 2, which is 1. And again, if I draw it out on a number line, so here's -1, here's +3. The distance between them is 4. So halfway means I'm here at 2. So if I just add 2 to -1, well, that puts me here at +1, which is what the formula gives me exactly. Okay, so easy peasy. So that covers 1D distance and 1D midpoint. Okay, so in the EQ5, how can we calculate points that, and let me make sure, okay. How can we calculate points that lie at fractional distances between two other points? So this one's kind of similar to my rationale here, more or less. Okay, so you'll see what I'm talking about here in a second. So we're going to use common sense, and then we're going to use a simple formula that we can derive from this. Okay, so x1 is at 3, and x2 is at 39. What point lies 1/3 the distance between x1 and 2? Right, well, what is the distance? So the distance between x1 and 2, so we're going to use our formula here. And that's very simply going to be the absolute value of 3 minus 39, which is simply just going to be 36. Okay, so 36 is our total distance, but we only want to go 1/3, right? So 1/3, about right there. So instead of going 36 all the way over here, we only want to go 1/3 of that. Well, 1/3 of 36, well, that's just 12. Okay, so that means I'm going to travel 12 from 3 towards 39. So that puts me at 15. Okay, so the point that lies 1/3 the distance between x1 and x2, and we're just going to call that P of F, point at a fractional distance. Okay, that point exists 12 away from x1, right? Which ended up being 15. Okay, so from this we get a formula, right? And that formula is a point at a fractional distance between 2 points x and 2 is always going to exist at the point where we're at x1 plus, we'll just call it f for the fraction, times our distance in one dimension. Okay, so let's see if that works, right? So x1 is 3 plus our fraction, so 1/3, that's this guy here, and times our distance, which is 36, which we already know that guy is 12. So 1/3 of 36 is 12. So 3 plus 12, and holy dog crap again, some mathematical witchcraft. Okay, I get the same thing. Okay, let's try it a couple more times. So example 2. Okay, so let's try our formula here for a point at a fractional distance. So point at a fractional distance is equal to x1 plus our fraction times the one-dimensional distance, or -28, it's my x1, plus my fraction, there's my fraction, 3/7, times the one-dimensional distance between x1 and 2. So I'm going to do -28 minus 14's absolute value. So I've got negative 28 plus, so what is my distance here? It's going to be 42. So 3/7 times 42. I'm going to go ahead and put 42 over 1. Okay, and really I can go ahead and rewrite this a little bit simpler. So just bring an arrow on over here. Okay, so I have 3 times 42 over 7 times 1, which is just 7. 42 over 7 is 6, so I really just have 3 times 6, which is 18. Okay, so then I've got negative 28 plus 18 now. That leaves me with negative 10, right? So we see how that works. One last example for this video, because this video is pretty short, barely at 11 minutes, so I might as well work another one. Let's use, what color have I not used? I'll use white, why not? Okay, so we're on example 3. Okay, so let's use our formula again. Point at a fractional distance is equal to x1 plus our fraction. So we're looking for a point 3/4 the distance between x1 and x2, right? Times our one-dimensional distance, which is going to be the absolute value of negative 17 minus negative 33. And we have to be careful here. This right here is a double negative. So the negative of a negative is just a positive, right? Okay, so then I end up with negative 17 plus 3/4 times, so I'm having a brain fart here, so 23/16. So 3/4 of 16, and I can use my little strategy from before. So this right here is going to end up being, so 3 times 16, all of that over 4. 16 over 4 is simply 4, and 4 times 3 is just 12. So what this ends up being is negative 17 plus 12, and my point at a fractional distance is thus negative 5. So negative 5 is 3/4 the distance between our x1 and x2. So easy. If you have any notes, if you have any questions, and we're not going to worry about that. That's more of a recap, and I already went through it. This is a video, so you can go forwards, backwards, however you need to do it, pause it. But anyway, any questions you have, shoot me an email. That concludes this video. Goodbye.